In this video, I'm going to be going over some of the things you can use in the standard template library. There are some very useful tools in there. And the first one we're going to look at is called a vector. Now, do not confuse this with a mathematical vector, even though they are related. This is basically just a flexible array. So come up to the top and include vector. And then let's say we wanted an array of integers, but we wanted this array to be flexible. Remember that an array is not flexible. It is set at whatever size you create it, and it cannot be changed. But if you wanted one that could grow, or in some cases even shrink, you could use a vector. So your syntax is going to start like this. You're going to write the word vector, and then you're going to put these angle brackets there. And inside the angle brackets, you're going to type whatever data type you want this vector to be. So if you wanted a vector of integers, you would type int in there. And this is your data type now. My data type is a vector of integers. And so after you write the data type, you write a name. And I'm just going to write numbers. And this is an array of numbers or an array of integers that can shrink and grow. Right now I have zero integers in there, but if I wanted to change that, I could come over here and let's say I want 10. So there's 10 integers and they will all be initialized to 0. If you wanted them initialized to something else, you can put a comma here and say I want them all initialized to 100. And that gives me a vector of integers, 10 integers initialized to 100. And now you can use it just like you would use an array. You use the name of the array, you use the brackets, and then we have elements 0 through 9. And I'll go ahead and change a few of these up just so we can see that they were all initialized to 100, and then I can access the elements using my array notation. This is also called random access. I can use random access to change the elements to whatever I want. So now I should have an array with 10 elements, 0 through 9. The first one is 15, the last one is 300, and I left all the ones in the middle at 100. And we could use a for loop to display these guys. We can say for int I equals 0, I less than 10, I plus plus. And then cout, we'll say number. We'll use our I to say which number it is, put a space, and then the value of the element. And again, we'll use that random access. Inside the for loop, we can just put I. And then inline. And that should display all of the elements in our vector. And there we go, 0 through 9. And starting at 15, we have 100s all through the middle and 300 on the end, as expected. Instead of putting a 10 here, the vector class has a .size method you can use. So you can say numbers.size. And now if I change my vector, the for loop doesn't have to be modified. The for loop will shrink and grow with the size of this vector. So how do we change the size? If I want to add more numbers, I can say numbers.pushback and add another number to my list. So let's add 13. And you can use this pushback method as often as you want to add more and more numbers to your array. And what's going on behind the scenes is you actually have an array, but when you push back, it copies all of those numbers that are in your current array to a new array. And then it throws the old one away. So it looks like you have a flexible array, but behind the scenes it's just creating a new array and copying everything over. And so that's how you would add an element. Now if we run our program, we should see that we have 11 elements with this 13 on the end. And we can also remove elements. So you can pop back will take one off the very back. You cannot pop front or push front with a vector. You can only add to the end. But push back adds and pop back removes. What if you want to remove one from the middle? So let's say I've got, instead of number 0, let's say numbers 2 is 15. Let's go ahead and verify that that works. And here I can see number 2 is 15. And I pushed on that 13 but immediately popped it off, so I don't see that there. Now let's see if we can remove this element number 2 from the middle of the vector. To do that, you're going to use erase, and then you need to tell it which one to erase. And erase requires an iterator. You can't just tell it, oh, we're going to remove number 2. An iterator is basically a pointer, and to get that, you're going to type the name of your array, and then you're going to type begin. That's going to give you an iterator to the very beginning. It's a pointer that's pointing at the first element in the vector. But we don't want the first one, we want element number 2, so we need to add 2 to that. And it will use pointer arithmetic to scoot us over 2 elements. That element will be removed, and then it will shift all of the other elements back in to fill that gap. So now, let's put a semicolon and test this out. And now my 15 is gone, and you can see it shifted everything up. All right, so that's the basics of using a vector. One other useful function is .clear. So if you wanted to erase everything in the vector, you can use .clear, and it will reduce the size to 0. Everything goes away. That's all well and good for integers. But what about objects? I've got a structure up here for an employee, and if you want to pause the video, you can copy this code so you can follow along. I have a string with a name default, $7.50 an hour, 40 hours a week. I left the gross at 0 because that would have to be calculated. But those are just some default values to set up this class, or structure, I should say. And then I have a display method down here. We're going to set precision to 2. Don't forget you need IO manip for that to work. And then we have a name, a rate, hours, and gross. We will display all of that information for any given employee in this structure. So if I want a vector of employees, I'm going to start by typing the word vector. And inside my angle brackets here, I'm going to type employee. And then I give my employees a name. And I will just call it E because it's short and easy to type. That's a vector with no employees. If I want to, for whatever reason, if you wanted to start off with a few, you could use that same constructor that we used before with the integers. Not done very often though. This is probably the most common way you would do it working with objects. Now we have an empty vector, so let's start by adding some employees. We can say e.pushback, and I'm pushing back an employee, so we'll type employee with parentheses. That will call the default constructor, create the object, and then it will get pushed back onto my vector. And let's set the name. So e0.name. We'll say this is, what's my default? Default is default, so this guy will be Fred, naturally. And we could also set Fred's rate and other things if we wanted to. We'll say his rate is $10 an hour. And that gives me one employee. And we'll just copy this information and paste it. And we could do this as many times as we wanted to. We could put Sally in here, $13 an hour. And we'll change her hours to something else. It can't be 0. That's a mistake. The 0 has to be changed because now we are 1 element up. So E.1.hours. We'll say 30 hours a week. So now we have 2 employees on our vector, and we'll go ahead and display that information using a for loop and say I equals 0, I less than E dot size, I plus plus, just like we did before, and then E sub I dot display. And that will call my display function for each employee in the vector. And this for loop is good for any size vector because I'm using dot size instead of less than 2. So there we go. We've got Fred up here with his information, and then we have Sally with her information. Let's go one step further. Let's say I don't want employees, but I want employee pointers. It's not uncommon to have a vector of pointers, especially if you're working with games or something that consumes a lot of memory. You have to get away from the stack and move everything over to the heap so you don't run out of memory. And so with game development, I use a lot of vectors of pointers to objects. And so our code's going to change a little bit. Now, let's say I want 3 pointers to start with. And then in order to have these pointers do anything, we need to create the objects. You can say employee pointer temp, I'll just call it temp, equals new employee. And then I could set all of this information just like we did before. And then to add this employee to our vector, we can say E sub 0 equals temp. And that will assign this first pointer in my vector of 3 to this employee. Now let's say we start with an empty vector. We would keep it similar, but we'll change a few things. We can say E dot push back new employee, and that's going to create the employee and assign the address to the first element in my vector. And then instead of saying temp, I would just be saying E sub 0 as we did before. But then instead of a dot, I have to use my arrow because these are pointers. And so it would look something like that. And we could add as many employees as we wanted to using this format right here. So let's test that out. And my display function doesn't work because that should be an arrow. And I'm missing my rate. Somehow my rate got deleted. And there we go, it works just fine. So that's vectors. They're just flexible arrays, very nice. Very convenient feature to have in C++. One word of caution, when you are working with vectors of pointers, you cannot just say dot clear. If I said E dot clear, it would wipe out all of the pointers, but my objects would still be out there on the heap, and then I have a massive memory leak. So it is important to run a for loop and delete everything first. So we would say delete E sub I, and that would delete all the objects, and then you could safely say E dot clear and delete all of the pointers. So if you're working with pointers, just remember that clear does not go out there and delete the objects. You have to manually delete them, and then you can clear the vector.